Your app is not slow because of UI. It's slow because of a bad networking. At scale, networking strategy determines battery consumption, latency, scalability, and user experience. Let's talk about high performance networking. First thing, the WebSocket, the normal HTTP, request, response, and close connection. The WebSocket connection stays open bi-directional communication. It is perfect for chat applications, live trading, real-time dashboards, multiplayer games. It is used heavily by WhatsApp, Slack. Why it's powerful? Because low latency, no repeated handshakes, real-time push. The architect considerations for this auto reconnect, heartbeat, connection lifecycle, and background restriction. HTTP/3. It uses QUIC. The benefits: faster connection establishment, better performance on unstable networks, reduced latency, improved packet loss recovery. For mobile network 4G and 5G, this is a big upgrade. When to care about this? If your application makes frequent API calls, servers global users, needs low latency performance, or modern CDN support HTTP/3 automatically. gRPC. Instead of REST JSON over HTTP, gRPC uses protocol buffers, HTTP/2, multiplexed streams. The benefits: smaller payload, faster serialization, strong typing, streaming support. It is used by Google and Netflix. When to use gRPC? Microservices architecture, internal service to service communication, high throughput systems. For public mobile APIs, REST is still more common. Request batching. Instead of make a GET request for user balance transactions, combine into post dashboard slash data or dash data. The benefits: fewer network round trips, reduced latency, less battery drain, especially useful in dashboard screens and home screens and super apps. Retries. Networks fail. Retry strategy must be exponential backoff. Jitter, limited attempts. For example, retry after 1 second, 2 second, 4 second, 8 second. Never retry immediately. Retry infinitely. Retry payment blindly. Throttling and rate limiting. Prevent abuse, battery drain, server overload, client-side throttling. Example: user typing search query, don't call the API every keystroke. Debounce for 300 milliseconds. Server-side rate limiting protects backend. Architect must design both sides. Connection pooling. Opening TCP connection is expensive. Connection pooling reuse open connections, reduces handshake overhead, improves latency. Modern HTTP clients handle this automatically, but architect must configure maximum connections and avoid blocking pool. Prevent connection leaks. Let's take a fintech example. If a user opens banking dashboard, application must fetch balance, fetch transactions, check notifications, validate the token, and sync pending operations. High performance approach: batch dashboard request, use HTTP/3, retry safely, and use connection pooling. Use WebSocket for live balance updates. The result: fast screen, low battery, stable system. The common networking mistakes: making too many small API calls, blocking the UI on network, no retry strategy, infinite retry loops, ignoring connection lifecycle, no timeout configuration. The senior engineer mindset when designing network: ask how many round trips per screen, what's the payload size, is this real time or request response, what happens on slow 3G, what's retry strategy, can we reduce calls? Networking is a system design problem, not just API calls. High performance networking requires efficient protocols, smart retry logic, batching strategy, connection reuse, real-time channels when needed. Thanks for watching and see you next video.